everyone. I'd like to welcome you to this first event of FR 25, celebrating 25 years of field robotics. And I'm very pleased to introduce the father of field robotics, Brent Whitaker, as our key speaker, and also this being something around Red's 60th birthday, so this is also the Red 60 event. Great that you can cover two of these in one. So Red, as you know, has been around at Carnegie Mellon since his days as a PhD student. Before that, he got a bachelor's degree at Princeton, and it's always been hard for me to reconcile my notion of a Princeton student with Red. So I guess he needs some big guys to, be tough around there too. He came to Carnegie Mellon and got a PhD in civil engineering in 1979. And he's been on the faculty here, both in civil engineering and as a member of the Robotics Institute. Red is best known for his artifacts. He's sort of thinking about robots as things that go out into the real world and solve real problems, doing things as they call it. There's a Japanese acronym that goes, translated into English, dirty, dangerous, and disgusting tasks. So robots have been out and about in nuclear reactors, underground in mines, off in the desert, in Antarctica, and at least conceptually, missions to both the Mars and to the Moon. I think of Red as really an engineer in the truest sense. If engineering, the concept of that is to take scientific knowledge and apply it to solving real-world problems. Red is sort of the epitome of that, both from many different types of science that need to be combined together to work in all the different environments and using the technology he has, and coming up with engineering solutions that sort of trade off all the different problems and can handle many different conditions and so forth. It's really a hard problem in field robotics, and he's really faced it very well. Red has also been great with people in many respects. He's been inspirational to many students. He's been inspirational to many researchers, and really been part of what makes Carnegie Mellon a leading institution and a real leader in computer science, and I'm very pleased that he's part of the School of Computer Science. So before he talks, I'd like to introduce Bill Pedudo, who is a member of the City Council of Pittsburgh. He represents District 8, which includes many parts of Oakland, Shadyside, and Squirrel Hill. He currently serves as the chair of the Committee on Finance, Law, and Purchasing. And he's been very supportive in many ways of Carnegie Mellon and of robotics in particular. And he'll read a proclamation today from the city of Pittsburgh. Bill.
Thank you, Dean Bryant. And just a really quick disclaimer to those of you who know me. I grew it so I could be Tsar Nicholas II for Halloween. And with a little bit of wax, I really have it nailed. And thanks to the folks at the College of Fine Arts, I have the most kick-ass costume for Halloween. Thank you, Carnegie Mellon, for so many reasons. How many people here, just a show of hands, decided to either stay in Pittsburgh or move to Pittsburgh because of the weather? How many people here decided to move to Pittsburgh or stay in Pittsburgh because of the Steelers? 3, 4. How many people here decided to stay in Pittsburgh or move to Pittsburgh because of Brent Whitaker and the robotics program at Carnegie Mellon? Exactly. Thank you. So when I was getting dressed this morning, it was only appropriate that I wear one thing. An appreciation of this man, this program, in transforming Pittsburgh. You are at the epicenter of what Pittsburgh will be viewed as. People are already calling us Robo-Bird. But the fact is that it's the continuation, the evolution of Pittsburgh. It's always been changing. But what it changes into is really going to be reflected by the people in this room today. That's why I get a kick. It was a great opportunity for me to represent. I would go crazy if I had to stay down on Grand Street all the time. I get refreshed and recharged by being with you and seeing the great ideas that you did and the promotion that you made for Pittsburgh. One that people used to think, and still sometimes do, is the Smoky City, into the Pittsburgh that you're creating. So I had to be here today to read this proclamation. Whereas the Field Robotics Center at Carnegie Mellon University is celebrating its 25th anniversary. And whereas the Field Robotics Center develops mobile robots capable of working in uncontrolled environments and performing tasks that are unsafe or dull for humans. And whereas the Field Robotics Center's robots have operated successfully inside of an active volcano, on the ice of Antarctica, inside of abandoned mines, in the basement of a crippled nuclear reactor, and amidst traffic on urban highways. And whereas the Field Robotics Center robots increase human safety and productivity and enable exploration under harsh conditions. And whereas William "Red" Whittaker is a world-renowned roboticist, educator, and pioneer in field robotics. It has inspired students throughout his career. And whereas Red Whitaker is celebrating his 60th birthday. And whereas Red Whitaker and the Field Robotics Center have enhanced the reputation and visibility of both Carnegie Mellon University and the city of Pittsburgh. Now therefore be it resolved that the Council of the City of Pittsburgh commends Red Whitaker and the Field Robotics Center for their excellence in creating new technologies that make people's lives safer and more productive. And be it further resolved that the Council of the City of Pittsburgh hereby declares Saturday, October 25th, 2008, Field Robotics Center Day in the City of Pittsburgh. Red, thank you.
So what's this field robotics all about? It's come to develop our world, feed our world, secure our world, and to explore worlds beyond. And that has occurred in the course of 25 years. The 25 years ago, there was plenty of science fiction, a great heritage in toys, and nothing in the way of robots. Something like this didn't exist, but it's at least the vision of robots in factories. And the important parts of it are that it's bolted to a factory floor, that it is very structured and contrived for success. That if you really can squint, you'll see the power cables coming in, the computer cables coming in, and no sensors in the scene. And at least there was a dream. And that's, so the robotics world, the research world, swarmed around that, and there was an intense pursuit of problems like this. There were some real robots, and in that era, the Hero was a big deal. It sold 10,000 units, and the Teach Mover was the desktop of the era, and so that's what was going on at the time this thinking began. And that a big part of the story was dreaming the dream of what there was to do, cooking up a technology, and creating the enterprise. This is a classic because it represents the best of navigation at the time, and if you can squint at the camera on top, every time the camera flashes, it goes to a different position. So this is 9-position stereo. And this videotape has been edited because it took over 10 hours to do this. And the only parts that you see are the parts that are the motion. And in between, there's the capture of the image and all the processing and the planning. And it took about an hour of processing before making a move. So I wanted to start us there as a baseline. And then the wonder is that if you move to the modern era, there are maybe 6 orders of magnitude of performance improvement, which are measured in many ways. And beyond that, the degree of difficulty in moving from those indoor settings and the factory into the open world adds another dimension to what's occurred over those years. And of course, this is antique footage because this is such old news that nobody remembers it. The half-life of the technology is about a year and a half, a little less. So besides the opening applications, these robots have found their way underground and into tanks and into cleanup basins, and have also performed dismantlements, construction, explorations. The one on the left, although not much advertised around here, dismantled a part of the CP5 reactor at the Argonne National Laboratory. And then the machines have also made it underwater and into the skies and have become an immense industry. And air vehicles alone are projected to attract $50 billion of revenue over the next 10 years. So all these facets are alive and well. And the thing to get is that none of them were dreamed about those years ago. And how, one of the catalysts around here is that image on the right where two plumes are active and there's a dead reactor. And the machine on the left was developed in order to perform the recovery of the basement of that crippled reactor. And that went to work and had 4 nearly flawless years. Along with it, a program to sample from the walls to determine the severity and depth of radiation. Very intricate programs with so much technology and comprehension in each of them. There's no way in a short presentation to relive that all. But something wonderful is that the people who made this happen are here in a room. And every time I look up, I'm catching another corner of the room where veterans that produce these creations are the real story. So even this one is not often seen with the skin removed to appreciate the complexity. It's actually succeeds because of its simplicity, but there are levels of reliability that are achieved through redundance and many ways to steer and drive. The short working video, and of course this is a story about transitioning from the structured environment and to go from tabletop demonstrations to real work, made a leap during this era. And that at least was the combination of the mobility with the manipulation and the controls, remote and automatic, that were necessary to make it happen. And this required working out everything from diagnosis to oversight to what was an appropriate means of controlling hours on end. And of course, the real story of that era was accomplishment, because there was the need of the time was to cross the threshold from speculation about what machines would do to that hard record. And at the time, robotics had a bad rap. It was still that fictional, this isn't real, it won't happen here. And these these performance changed a lot of that, and still have changed, have gone on to change how much of that service and accident response occurs today. So the other revolution of the era was this big idea about going outside. And in the community, this was preposterous. This was, things weren't doing very well in the hallways inside. And so there were these concerns about the idea that if you go outside, the appearance of trees and vegetation would change with the seasons. Concerns that there would be curbs. There were concerns that there wouldn't be a plug. There were, so this, if you catch the middle of this, there's a circle that is dipped in paint by this machine, and that's the means by which turning was calibrated at the time. And then it, of course, went on to lead the state of art and practice for a good many years. And then that same group of creators that started together and stayed together are still around. They still make these six-wheeled machines. And things do change. So I mentioned that mobility was one of those things that wasn't around and had to be there. I'll talk more about navigation and the other technologies that get layered on, but a first fundamental requirement is to move. And then the story was to move with a quality of perception and navigation. And even though this one is really old school, and this goes back to, I think, 2004, that even in that era, it was a leap of performance beyond what was there before. So the way in which these machines model the world, of course, differs from our own, but is highly operational and effective. This is a three-dimensional model that is built, in this case, by laser, but commonly now by radar, commonly now by camera, commonly now by all of them fused together. And that part of the ongoing story is that the sensors that get this job done and the processing that's behind them continue to innovate and change drastically every year. The planning part of it is a little like a MapQuest or Google map of an intended route, and then these machines fill in the detail as it is revealed, and plan and drive and control to execute those best plans. And so some variation of this exists within every robot, every autonomous robot. And of course, by this time, the charter is to autonomy, not just in this competition, but for other reasons I'll get back to. Now, the technologies are actually pretty shallow, they're pretty irrelevant if a movement, a discipline, doesn't determine what there is to do with them and push them into relevance in the world. So this is actually significant in that it was it's now about, no, at least 19 years old. And it was pretty amazing for that era. So before this era, and before this project, the GPS constellation wasn't in the sky. There was no sense that you could use it to drive. There was a lot that was taken on faith. And then the good news of going that boldly that early is that given that you have what it takes as a team to succeed, you didn't have to be particularly good just first. And so there's a tremendous amount of patenting, and of course nobody, it'd be very difficult even today to match the performance of that while it continues. Driving trucks around is something that makes sense whether or not you load them, but something fundamental to this field robotics is digging in dirt. And there are technical descriptions of it, which is manipulating diffuse media. It's essentially working in a sandbox versus the kind of discrete objects like cubes and objects that were the standard of the factory at the time. So as you view this, you want to look at what spills out of the bucket, the way in which the understanding that spillage while loading a truck is a big part of the planning, and the idea that the motions and the events anticipate, in part because you start to spill while you're in motion and you're still spilling while you're still moving. So these are a little, they're a little more intellectual than first meets the eye, which is not to use that as a particular measure of the time. Now, there actually was a generation of this that went back something like 85 or 83, around then. But the thing, and for anyone from Pittsburgh that knows Four Systems and Francois Bitz, this was one of his developments. But the thing is that if you really trace the history, when this community just got started on digging, since there wasn't an understanding of all of that planning and force control, what we did was to create vats of jello, and then with robotics, dig the jello. And to refine that as process over a long period of time before going for the dirt. Another that made sense was to pursue farming. And remember, a big part of this is sorting out, what do you do with it? And this wasn't at all apparent. We either didn't see this or resisted it for at least a decade. And then at some point, it was right seminal work to pursue. So this takes it a step beyond driving around to performing work, and that in addition to seeing the road, this one has to take the step up to sense the crop. For those that are close to the culture, this was the flagship project that kicked off the Robotics Consortium, which is the kind of spin-off that then takes life of its own and grows into something even more over the years. One satisfaction, what you're looking at now are aftermarket kits that you can bolt onto an old tractor. So you can either now buy it that's developed in or added on. And of course, if you're close enough to see the symbols on them, they're They're actually fierce competitors. And so when a discipline gets to the point where it's putting product out there into the workplace and that it's hotly competed, that's actually a step up from just getting it into products and getting it into the world. So I mentioned the underground, the world of the underground. This is shown with that sensor that's on the top is a wagon wheel of a lot of sonars. And that was a really, really, really big thing 24 years ago. And that was big stuff. It didn't work, but it was big stuff. And so there were researchers in this building just completely striking out. And the big strikeout is that these sonar sensors failed with reflections from the glass and the doors in this building. And the moment that it went into the underground mine, it succeeded the first time because of the roughness of the walls that gave good readings, that gave good models, that gave good navigation. And that's a perfect example where anticipation and cultural reaction wouldn't work. And this is really, it won't work. Just evaporate in a moment as soon as you try them. And of course, they've continued to work in big ways. So this is a whole field in its own right. This is an example of an excellent map that is produced of an abandoned coal mine, and an early robot that made that map. And we're really digging into the vintage footage here, but this is from some of that earliest mapping. That's why the map is so crude, and it's why there's no floor on it. So you can think of this like a rat in a maze. It is making its way into unknown territory, and it models as it moves, and then it uses the model in order to move. And it's also solving other problems. It's solving a network problem because it doesn't know what these intersections are and how they loop back around. And of course, it's conscious of power just like a laptop, because in an abandoned mine, the most important thing is that a machine gets out. And then there is one of the reasons why this was a nice early problem around here in connecting with what there is to do is that this is Pittsburgh. Those of you who are from out of town are visiting Carnegie Mellon University. And Carnegie was a great philanthropist of his era. But before he gave all that money away, he made the money as an iron-fisted industrialist. And that all came from the energy, the coal. And you're actually sitting on 5 seams of coal right here. And then there are hundreds of thousands of these abandoned mines. And there's still more coal down there than anybody ever took out. And the way that that coal will be worked, because energy is worth something now, is that robots are going to be how it gets done. Anyway, some of these big mines have over 1,000 kilometers of these corridors. Yeah. And the robots get better. And the glory shots become a little more beautiful. The mines are never lit up like that, except when you're taking photographs. I mentioned that basic loop of sensing and making a model and making a plan and driving is intrinsic to all these autonomous robots. 2 great distinctions here is there's no GPS and there's no communication. So even though there are many machines that have autonomous capabilities, there are certain classes of machines. Machines to the planets, machines in these abandoned mines, where you can't really send anything to repair. And that these call for greater and greater levels of autonomy, that the motivations for these are vast. I just checked to see that over 5,000 workers were killed in Chinese coal mines last year. And then, of course, I spoke earlier about the value of energy, and there are always undiscovered ways to apply these things in production. So then, a quick series on environment. And not sure what's really happened in our world. I can't say when I was coming up as a kid that much anybody looked at the environment. But robotics have had and have a huge agenda there. This one is asbestos removal from pipes. So if you see the pipe to the left, it's clean iron. And if you see the pipe to the right, that's asbestos. And then this is a device that moves along that to remove and package the asbestos. And this is one that saw duty in this one was unique in being able to fold up, get into a small space, and then open up in order to do the work. This is, for this kind of work, cleaning the tanks. There's it's application where size matters. And then mentioned a word about this before, and that other manipulation that made it to CP5 was the dual arm. So at one point in the evolution of manipulation, the dual arm problems were the big thing. And then, of course, that's true of the heavy work also. And then this, a lesser known, this is actually Grand Challenge technology that surveyed about 1,800 acres, which required about a mile to an acre. So think of it like 1,800 miles of autonomous driving. And then it's towing those sensors that look on and under the surface. And this is one of those sites that has a lot of heritage that is contamination and objects that are that ultimately will be removed. So the projection always obscures it, but you can almost pick off the parallel tracks of that methodic lawnmower pattern that would have inched out very accurately all that acreage. And what we're seeing here is something that actually couldn't be done to the persistence and accuracy by a human. You know, it's another way that those cultures change. This was originally offered as a traditional human contract with the kind of people in suits that just walk and wave wands. And then when the Grand Challenge succeeded, the offering of the contract added language to accept autonomous robots. So, you know, if you're around enough, you know that all these things change. And because in a movement like this, ultimately you change regulation, there is new law that's written. Cultures change. So about changing cultures. These grand challenges shift things big, and they shift things quickly, and they shift things forever. And the most visible ones are Lindbergh crossing the ocean for $25,000, and this recent one to space for $10 million. So I won't take any time to revisit Lindbergh. One that was real big around here was a computer defeating a human chess player. And that's also getting old now. It's like 11 years ago now, 12 years ago. But I mean, before it's done, people really don't believe that a computer can beat a pro. I mean, it's deeply enculturated. And then, of course, after it occurs, there's just nothing to it. And gaming has turned into something. And that there's an interesting business that's coming out of that space venture. And robotics has been blessed by having 3 successive prize challenges. Because the reality is that they are always around, but for an emerging field like this, to have 3 of them back to back, that's opportunity. And then back in 2004, there was this was actually a very short fuse, because the reality is that between the announcement and the competition, there were just so few months. And like all challenges, you usually don't get the fine print and what the rules are about until much later in the game. And then even that would lead to the kind of, say, environmental technology that I just showed a moment ago. And then that was followed by a challenge for driving on town streets. And this institute has been in that game for a while. I actually don't recall the date. Would this be about 86? About 86. And this one, it's interesting that it's shown in the snow, because it was actually built. We built it outside. We didn't have a shop. So we had this, it was on the loading dock over at Porter Hall. And anyway, it went on to have good technical life. And that, because all these things are built on the shoulders of what have gone before. So in this, if you see a moving sensor, that's probably a robot, and if there's not a sensor, that's probably a human. So that would be robot. And this is some footage that's, so this would involve then the planning that would consider intersection precedences, interactions with other vehicles, safeguarding in the face of other machines. Probably the biggest leap that occurred in this competition was engaging moving robots from moving robots, and that the mastery of that was a big distinction. I love this truck. That's my favorite. Anyway, there were a great number of new planning challenges, and that one of the sensing evolutions was this improved laser scanning that had great range, was able to see all around the machine, and was fast enough that it could pick up motion of this machine and motion of others. And the robotics hasn't really pushed hard into the automation trade, which is arguably the largest market that we'd consider, even though some of the technology isn't quite there yet. And there are a lot of accidents which call for safer cars. And then within the accidents, there are certain types that occur with teens and certain types that occur with older drivers. And then the off-road industry is a much earlier adopter and much more aggressive in putting the technology to work. So the obvious part that comes out of these is that there's a check, and when you get that kind of a check, you cash it. And that's really not the big deal, because the reality is that it's never about the money. It's never about that kind of money anyway. And these are huge infusions of capital into the research and into the technology. They are tremendous corporate relations. They are tremendous transfers of technology into products, great means of developing people, teams, experiences that are for life. And if all were known, they really do change the way the world thinks about all this. Keep changing the way people imagine that things can be done. And that brings me to another prize that is on the street. It's backed by Google. The criteria on the left: if you land on the moon, drive 500 meters, broadcast video, you collect the $20 million base prize. And then there's bonuses. If you launch from Florida, you travel 5 kilometers instead of a half kilometer, visit a historic site, stay overnight, or find water or some combination. That's it. The thing that's so wonderful about these is that it's not all of the, until you're in it. Of course, I realize there are people with just such vast perspectives on how they, until you've seen program definitions and contract language and some of what goes behind getting things done, it's hard to just appreciate the simplicity of something like a desert race with its just drive 200 kilometers and get there first, or fly from New York to Paris and collect your check. And so we are not prize junkies, despite possible appearances that the field robotics community has been pushing robots on other worlds for some time. In fact, here today, we have people with us that arguably are the ones or the one that's made it all happen. I can't wait to hear some of these talks tomorrow. But just here at home, great studies of missions, landers, robots. An innovation of this one on the right is the use of the sunlight that appears near a planetary pole, and that's something that took us up north of the Arctic Circle. This is a favorite, an old favorite. This footage was from our favorite desert, the Atacama in Chile. And the important thing to get is that even though this is vintage technology, these are machines that did a great job of getting around, staying out of trouble. Some of the innovations on the top of the machine were pointing antennas for communication. This was actually the first fielding of one of those curved, the sensor that seems to be flying in the air up front is a curved lens, so a camera looking up and out to get the panoramic shot from one frame. Anyway, other ideas of how to go after the ice, which includes getting down into the craters, which includes getting down into craters, and lots of different forms of this over time. Great. You look at the machines. It was interesting that to be known for the artifacts. This on the purple one, that mast, that horizontal mast that shows the devices that are like cans. That's actually the first field implementation of trinocular stereo, and then it was done twice. So it's 3 cameras that work together and 3 cameras that work together, and together spanning a wide field of view. On the top, near the higher up the mast, is the first of the spherical scanners that got the full wraparound laser view of the world. Pass on the movies. Well, I won't pass on this movie. This gives the appearance of driving, which it is doing, but the purpose of this machine was to search for meteorites. It's a phenomenon. It's just great. It's so good to see Bill here. So a lot of people that are inspirational to me are here with us today. And the thing that's unique about this is near the cursor there is a meteorite, which is one of the 5 that were distinguished by this fairly forward-looking idea. And as is characteristic, taking it from the idea to the field to show how it'll work. So recall that there's a bonus for a historical site. Our intention is Apollo 11. We believe that'll have a certain appeal that other sites don't. This is where things are with some technical development, and that is not photoshopped, except for the Earth. So if you can keep that picture just for the next frame, that's how it goes on top. And the idea is that it's a little bit like Buzz Aldrin. It's the robot is the thing that flies us in. And then just the things that are underneath are the parts of the spacecraft that it flies. And then after slowing down, this is what alights. And that's what it looks like. And then the robot separates and drives away. And immense initiative to prototype and refine and test and develop, because all these things take all that. Some part of it has been connection with people. I won't over-represent these because so many of them have found their way into the world in other ways. And it's amazing to see what has become over the years of animatronics and things like docents and restaurant guides, and there are human interactions that are a lot more than entertainment. This one is a device and interaction for teaching Braille to the blind. And then, of course, the real story behind any look back is people. And there's just always been people. around in the doing of it, and that I'd say half that gang is here in the room now, and that this is one of the crowds that did the first autonomous entry that was a long traverse in a mine. Something from the old days in the desert. I chose this just knowing that at least one good friend of this showed up today. So that's back at base camp after Erebus, which is nice to get back down low. And then one of the challenge teams, and the youngest character in the challenge team. Actually, my view of these things is that the future is always in good hands. And sometimes you think of generation as being like 5 years or 10 years or 20 years, but the way that technology and the people move, a generation is more like, I don't know, 2 years or 4 years. And it seems like a culture like this is an eternal fountain of youth, and that people are always coming up, and that greatness always is arising. So I've already made it big in the development, feeding, and securing and exploration. And this is one that I pulled from the 10th. So this goes back a lot of years to show the beginning of the family tree. And then in addition to these, so at some point there was a species that went underground, and then in addition there's another quadrant for the air machines and the water machines and the space machines. And in that time, many of the revolutions have not been robotic. So it's gotten where it's going because somebody else put up GPS. It's gotten where it's going because LiDARs and cameras have had a good go of it. But it wasn't accidental. And there are reasons at every step why it's invented and reinvented and continues to be revitalized. The picture is me, but of course, at some point, that founder is irrelevant in how it all moves ahead, because it really is. It's unstoppable. There's no taking it back. And in the beginning, there was no way to start it because there's so much doubt and second guessing that it's very difficult for a movement to emerge. But then once it's there, it's in for good. So I like this photo. I was out on my farm when we were testing, and people up front could actually see that there are two rainbows there. And I just always re-look at this when I think about how bright that the future is for this work. And so when we're back here 25 years from now, I really look for field robotics to dig into the great cleanups of the earth. The one from my time, an old one from my time, was Bhopal. It was in India. And it was an event that took out lots of people in a day. But then since then, it's taken out so many more. And that's the way the great accidents like Chernobyl work. And there's a tremendous agenda in our national cleanups. Robots have ways to farm that are very different than big tractors like people drive. And once there are innovations in how we manage weed control and till. There are huge opportunities for changing the way that's done. Mining, just as I'm mentioning these, a lot of people are quite disconnected to field robotics because it's not a sense of their everyday day. In other words, most people don't go to work farming or mining or cleaning up a nuke or looking for life on the bottom of the ocean or heading to space. It's just not done. But the thing that can be missed is that everything that humans have and everything that humans eat start from some form of farming or mining. All of it. And then to really see, whether you look at it economically or operationally, those are ones that are moving big and moving fast in the world. In 25 years, robotics are going to have a planetary agenda that's much more than driving around and exploring. There will be cars in some forms, all of which will be safer and some of which will be automatic, at least in some types of roads. Accident responses. They don't have to be a Bhopal or a Chernobyl or even, it's so interesting, even if there are a couple of hundred miners that are trapped somewhere, we still get the calls. And there's a point at which that's just got to get out in the world and outside of the hands of university research. And then discoveries are like the last 25 years. There was about 10 years ago, Americans got a thing for the Titanic. It was, just like the movie, and wanted to see what was in the dining room, and of course, some of the most interesting life forms are at those vents at the bottom of the ocean, and when but putting that classical kind of exploration aside, all the things that everybody in this room does is discovery in its own right. So that's unstoppable, and when you think of this come from nowhere bootstrap that is almost an imposter, right? It's just getting started, that the best is surely yet to come. Anyway, that's the time. It's been a pleasure. So have the 25 years. Thanks for coming. So of course I'm around, and please feel free to get up and get on with things. I mean it when I say it's about it. So are there any questions? Easy audience. Everybody, I'll tell you, at least half the crowd are insiders. At least half the crowd have lived it. And by the way, for anyone who wasn't an insider, I commiserate. I wouldn't, what it takes to do it, it's enough. So, anyone about anything? Make something up. Yes?
It sounds as if every application is to order, a custom application. Do you ever see robotics as a mass-produced item that could perhaps be manufactured in Pittsburgh?
Absolutely. seeing things like that, there are some pretty fair examples of things like vacuum cleaners that work inside a house. You might not think it's the ultimate application, or maybe the vacuum cleaner doesn't even work that great, but the metric for something like that is that you made them, you sold them, and you made some money. And there are plenty of those yet to come. If all were known, there are, for example, in the Pittsburgh region, there are great producers of mining machines, technologies that go on to mining machines, and then there are lots of these machines that could be produced and commercialized here. I only hook back to coal because it is one of those economies that is very advantageous. Anything else? Yes?
You denigrated the first Grand Challenge project.
I never denigrate anybody, and so I blew it. I blew it if I screwed that up. So the first Grand Challenge.
As old school.
Yeah.
What makes it old school rather than just old?
I'll just see if I can find it again here. Well, for starters, you may be aware that this Hummer was bought. It was the first year of production. I bought it from a farmer. It was 25 years old when we picked it up. It had no electronics whatever in it, no power, no braking controls, no steering controls. So it's so common when you modify or alter a modern era vehicle that you tap into the bus where you would access things like engine controls, speed controls, brake controls, things like transmission shifting and the like. And when it's the old way, you build in the motors and the mods, and you start from scratch on everything. And then the other that's about it is that the electronics box, as you may see here, occupies the interior such that it's impractical for a human to be in it. And if you don't have a human in it, then while you're developing and while you're working out bugs, you're not right there. And so that degree of difficulty for evolving and getting it worked out is very, very, very high. It is unforgiving in lots of the ways that you'd expect from modern vehicles, everything from tip-over stability control to skid-proof braking. And then when you go up to the into the electronics and software, the computing. I mean, you'd have to refresh me because just in that interim, there were single cores to dual cores to quad cores, right? So the do nothing part of it, just doing nothing, that part of the power goes way up. And then this one would have done so much mechanical stabilization with the old school thinking that you had to get a stable platform for the sensors, since you couldn't sense and process quickly enough to take the oscillation and the movement out of the machine. And now all that thinking is shifted, knowing that you just hard mount right to a body, and those perception planning cycles move quickly enough to get the job done. Something else? Yes?
We used to think that good hardware would beat good software 99 times out of 100. Would you say that's changed?
Well, software is always late. It's always the software guy's fault. You know, all that religion about whether software counts or hardware counts doesn't really make it in the face of anything that I've ever seen. In part because if you don't do it all right, you haven't done any of it right. And that they're each evolving so quickly that whatever you thought 2 years ago doesn't mean it. The software has evolved so much in content, and part of that's the understanding of the underlying technologies, and also in its implementation, engineering, and the availability of everything from operating systems to the reusable software. So many times when something like this is undertaken, it's done this. What I didn't mention about the cleanup machine, not the cleanup, the survey machine in the desert, the one that went 1,800 acres, that development till the time it got the job done was about how long?
3 weeks. Oh, you mean
Not the operations, the producing the machine. The machine couldn't have been produced in 3 weeks. So I realize there are claims about it, but you want to see that that robot came from pretty much nothing to everything in a month. Yeah. Now, okay. So I mean, you could say, well, you know, people are pros, but the other side of it is a lot of it is cut paste, because you get to the point. It's getting back to the question of, you know, could you replicate? Can you cookie cutter? It's never exact, but it's close enough. Something else? Yes?
This software is always late. When you're going to the moon, are you planning to put the software up after the launch?
You never plan. And then something that's designed in is called a backdoor. And that's the means by which you can circumvent, because all best plans go awry. And then that is the means by which you can still get access, no matter what's going on, to do those modifications. And of course, it's done time and again on Mars. However, this ain't Mars. And what we intend to go for one illumination light cycle on the moon, which is another way of saying for the first mission, 12 days. And the difficulty with that, even though they're real 12 days, they're 24-14 days, or 24-14, 24-12 days, if you measure it that way. It's 200-300 hours of continuous light, which is continuous power, with more power than you need to operate. So it's not that mode where you charge up and you get enough power and then you go. This is unrelenting, non-stop, high production performance. And when you're stopping to rethink, troubleshoot, upload, you're in real trouble in a short mission. Anything else? Yes?
You said some of the drivers for
Nice.
this technology was the prizes of the challenges for it. And I just kind of wondered, as we look out into the future, we also talk about, Caterpillar, some of the early adopters. I just wondered how much the military is going to help actually implement and also fund some of the vehicles that are going out in the future, and kind of what time frame.
Military has, does, and will drive and propel field robotics, at least one sector of it, throughout your lifetime. And it's such an interesting issue because, of course, there are all kinds of different perspectives on conflict and intelligence gathering and combat that's in a room like this. And a lot of those perspectives change on the eve of conflict. So the night before the first Iraq War, there were all these CNN issues what will happen, how many will die tomorrow, who will get it. And there's such a regard for humanity and human life that robotics are finding such interesting roles. And then, of course, whatever's accomplished there works in the commercial world. So, for example, I mean, they're all examples, but the flying machines that are so prominent in oversight or reconnaissance and looking over a scene are one of the greatest commercial successes, and have sold nearly $1 billion of small helicopters into agricultural applications for rice paddies and mountain farming. And even though there are reasons why security and defense are interested in going through sewers and getting under a building like this, there are other reasons why commercial companies will map a sewer and charge a municipality or an environmental organization for doing it. And so it's unquestionably here to stay. And it's, I mean, that, there are some of these machines that will absolutely strike, they will strike awe into anyone. I mean, there are some pretty ferocious, effective robotic machines that are out there. Anything else? Yes, the back.
Most of the examples that you showed were of machines that weren't really operating around people. And I assume that from a businessman's point of view or from a lawyer's point of view, there might be liability issues if you have a robot, let's say, driving around in your streets or mowing your lawn. For example, a robotic lawnmower might be very nice, but it might run over your dog. So has any work gone into studying how robots can be made to be safe, to work around people?
The whole initiative that's human-robot interaction, and that looks at the obvious physical things like a robot being here and a human being here, and also those other issues like how do you convey intention, how does the robot communicate status, what is that mix of safeguarding and intention. There's a lot of that has to go on. Almost any robot, no matter how autonomous, still has to be serviced, set up, set in its course of action. So even going back decades, those nuclear cleanup machines had first to be safe enough to be operated in the presence of people, tool changing by people, sample recovery from the robots by people, and all the issues that were interconnected with what people in the robots were doing and what could go right and wrong. And quite honestly, these issues are the rich, wonderful things that go on in every product introduction. So every time you put a safety feature into a car, a robotic safety feature into a car, that conversation is the one that goes on. And so that goes on before there's automatic braking, before there's tip-over protection, before there is enhanced cruise control, and every time there's a human and a machine with computers that are in the mix. I think it's really important. By the way, I'm here for the duration. I'm alive. I really love it, and I really want to encourage people to be good to yourselves and trickle on out. There's no obligation to spend the evening. Great. See you, Dave. I'm sorry. Okay, and that's a closed reception or an open reception? Oh my, okay. So what I just learned is that I have made the worst of offenses. There's actually food waiting for us. It's in the high bay of an adjacent building. And beyond that, it's important for us to clear the room because it's being used for another seminar. So with that, the last word. Thank you so much for taking the afternoon.